The next property, that semi-group.
and not. So natural number with negative subtraction is not able to be algebraic structure. That means no need to further study for them, right? Cross out all those things which even are failed to be closure, satisfy the closure property. Okay, even this. No need to check further. First only they have failed. Okay. So likewise we can study the sets. Now these people, natural number with addition, whether they are semi-groups. So let's see what property a semi-group should satisfy. Okay. So semi-group says they should also satisfy with associative property. Okay. Associative property. What is the associative property? A set with respect to any operation is said to satisfy associative property if for all elements, for example ABC, that belongs to the set, then it should satisfy this associative property that we have seen earlier also. A operated with B and then operated with C should be equal to B operated to with C first and then A. And then the set is a semi-group. Let's see about natural number with respect to addition. Okay, so let's take any number and whether addition is going to make a difference what you do first and what you do next, it doesn't matter for addition, right? Whether you do this way or whether you do this way. Okay, and we know that addition operation itself satisfies a associative property, right? So even if I do this, will be the same equal to result for this, okay, because it's an addition operation. So I can say natural number satisfies the associative property. That means they are a part of semi groups. Okay, so natural number with addition are semi groups because they satisfy the associative property. Okay, what about natural number with multiplication? Let's see them. Associative. Okay, so natural number with respect to multiplication. Whether multiplication also makes a difference in this theory? No, for multiplication also result doesn't matter what you do first. Any multiplication operation can be done first and next. The result is going to be the same for all natural numbers. Even we take 0 in or any other number, then the result is going to be same. That means natural number with respect to multiplication also satisfies the associative property. Right? This is done. What about integers? Integers with respect to addition is going to be the same. Integers, whether it's going to make a difference if I add two integer values with respect to addition here. Right? Here itself I will do. So again for integers also it doesn't matter. Okay, so for integer numbers the same thing will be whatever numbers, even a negative number, if we add first, the result should be equal to, you can give any example when required. Okay. So here the what things we will get here? Minus 3 plus my plus 3 will be 0. And what about this? Okay, minus 2 and plus 3 is minus 1, minus 1, minus 1. Okay, okay, it is not proving out to be. Okay, how come integer actually it should minus 2, okay, plus 1 and minus 1, sorry, is again a 0, right? So integer with addition also is not going to make a difference for associative property. It will satisfy if we solve, okay, accordingly. It will be plus 1 and minus 1, right? Do for any numbers, any integer you take. As it is an addition operation, you will get the same result. Try associative property with that. So integers with respect to addition also are satisfying associative property. So they are also a part of, they became a semi-group. With respect to subtraction, okay, integers with respect to subtraction, we have said abelian structure. No, it was not, right? As much I remember, closure property with respect to division it is. Subtraction, we have not seen only, I feel. So let's see integer with respect to subtraction, whether they form to be a closure. That means the result should be a part of, yeah, they are. They are the part we by default guessed. Now talking about associative property with subtraction. Let's see associative property with subtraction. Here, subtraction. So do we think they will satisfy? I don't think that will make a difference now. Okay, it will not be possible because subtraction is some kind of not associative one. So let's see how it makes a difference, because the larger number comes out to be plus and minus here there. So these operations will never. Now it will make a difference. Should I take a simple one? Plus 2. And we can see it will make a difference. So minus 1 minus 2 minus 3. It will come out to be minus 6. And see this? This is minus 1. And this comes out to be 0. Right? And that's why integer with respect to subtraction will not satisfy associative, because association, when we change, subtraction doesn't prove out. So this will not be a semi-group. Integer with respect to multiplication, let's see, integer with respect to multiplication. So if I associate multiplication like this, does it make a difference? For multiplication, it will not. Okay, all the values are going to be minus 2, minus 6. Okay, and here 6 into minus 1 again, minus 6. So we are always going to get the same result. That means multiplication with respect to integers prove out to be a semi-group. Right? Now, who was not able to? That is integer with respect to subtraction. They can't be semi-group, so definitely they can't be further any. Right?